So now we're looking at 3.2. So these are postulates and theorems. So we just did parallel postulate, and I think you just had parallel postulate for your last, for 3.1?
Parallel
and perpendicular. And now we're looking at corresponding angle postulate, alternate interior angle, alternate exterior angle, and consecutive interior. So we've talked about what each of these are. I'm going to draw a picture. Okay, corresponding angles, remember, are right here. Could be an example of one. Alternate interior angles, right here could be one. Alternate exterior, on the outside, like the exterior of the house. And then consecutive interior. And how is consecutive interior different? They're not equal, they're what? Supplementary. Okay? Alright. Do you need another second to copy these pictures down just in case you want them? Because then it's going to disappear when I turn it off. Okay, they don't have to be perfect. You can always look on the last page. You can always look on your last page. There's pictures on there too. Okay, so now we're going to go over the proofs. Okay, there's two proofs. So we've got this first one. You should have, oh, this is not the right thing. Excuse me, this is not the right thing. Okay, so we need to draw in this picture. K and H, cut by a transversal, and then we've got angle 1, 3, and 2. We know that K is parallel to H, and we're trying to prove angle 1 is congruent to angle 2 without using the alternate interior angle theorem because we're proving that theorem. Okay? So we say K parallel to H, what do we call that? Given. Now we're going to say the measure of angle 1 plus the measure of angle 3 equals 180, and we call that consecutive interior angle theorem. And you need to know the difference between which one's a theorem and which one's a postulate. Okay. We know the measure of angle 2 plus the measure of angle 3 equals 180, and what do we call that? How do we know 2 and 3 add up to be 180? What? No. 2 and 3 add up to 180 because it's a linear pair. Linear pair postulate. Good. Next, we know the measure of angle 1 equals the measure of angle 2 because of congruent supplement theorem. If two angles add up to 180 with the same angle, then they must be equal to each other. So then we've just got to change this to angle 1 is congruent to angle 2. What do we call that when we change it from equal to congruent?
Definition.
Definition of congruence. Good. We got one more to do, guys. We're not going to do example 3. We're just going to do one more. Yes?
For linear pair postulate, don't they need to be opposite of each other?
They need to be forming a straight line. 2 and 3 form a straight line. 180 degrees. You're thinking of vertical angles. All right, let's move on to example 2. Okay. We've got 2 lines, M and N. We've got a transversal, angle 1, 3, and 2. We know that the measure of angle, M and N are parallel to each other, and we're trying to prove 1 is congruent to angle 2. Now this is the alternate exterior angle theorem, but we can't use this to prove the theorem. What's the first thing I'm going to write down? The what?
Given.
So M is parallel to N, given. What else do we know? 3 and 2 are equal for the vertical angles. What else do we know? It's something we just learned today. 1 and 3 are congruent by what? Corresponding angle postulate. CAP. Corresponding angle postulate. Now we've got 3 is congruent to 2, and 1 is congruent to 3. So, transitive, good. Angle 1 is congruent to angle 2 by the transitive property.